Okay, before we move on, let's take a look at some vellum grain basics. So we can turn this stuff off. And let's go to the first frame. And let's make a geo. And let's call this grain source. Go in and let's turn a box into vellum grains. So we have our box, press G to reset. Let's place it on top of the origin, like so. And we're gonna use the shelf tool now. So we'll go to vellum grains, and it says select objects for vellum grains. So we'll select the box and press enter. And this will create a couple of things for us. So we have our grain source, and it created a DOP network and it created a import geo. So let's take a look at the DOP network. And inside here we have our vellum source, which is our box right here. We have a vellum object, a vellum solver, and we have a gravity force and an output. Now, when we press play, the grains will just fall down, so we need to add our ground plane in here and make sure this is set to mutual and collide relationship. So now when we press play, the grains will fall down and collide with the ground. Now before we continue, let's add some more grains. So we'll go into our grain source, and it created a vellum configure grain in here with some nulls. Let's look at the grain size. So we'll put the flag on here. So right now we have 1140 grains. We can make this always view in the viewport like this. So let's add some more. So we'll reduce the grain size. Now we have 10,000. Now we have 20,000. So let's start with 20,000. That's fine. As you can see, they're all arranged perfectly. So later when we use this for our ship, we'll check the jitter scale. It will randomly position the grains, so it's more of a natural look. But this does take some computing, so we'll use this later. Okay, so now we have some more grains, 20,000. Let's go back to our DOP network. And let's play the simulation. Now this looks really bad, and this is due to our substep count. So in our vellum solver, the default substeps is 1, and this is not enough for grains. So we need this to be a minimum of 5 substeps, but we'll set it to 10 to get a decent stable simulation. Let's take a look. So that looks way better. Now, there are a couple of really important parameters that we need to pay attention to. And we can find those in the vellum solver under advanced grain collisions. So inside here, the most important parameters are the repulsion weight. Now the repulsion weight is a number from 0 to 1, and it will tell you how many particles will collide with each other. So at 1, all of the particles will collide, and at 0, none of the particles will collide. We'll keep this at 1 for now. And another important one is the attraction weight. This will tell us how much the particles will stick together. And this is very important for giving us a dry or wet sand look. Because at a value of 0, none of the particles will stick together. And this is a dry sand look. And when we start increasing the number, which is very sensitive by the way, so we need to make minor adjustments. But when we increase the number, the more particles will start clumping and sticking together. And this will give us a wet sand look. So we're gonna keep the attraction weight and the repulsion weight at default for now. And we'll create a couple of copies. I'll select these two and copy them. I will call this AutoDOP network 2. Copy them again. 3, all right. So inside the import geo, we have to assign the correct auto.network network. So we need auto.network network 2, so this one is correct. And this one has to be, whoops, auto.network network 3, so this is fine as well. Now I will, so this is all using the same grain source, by the way. So now I will offset each import. So this is our number 1. I will set it to -3. This will, or maybe -4. Have some more room. This one will be at 0, and this will go to the right. Okay. Okay, so now I have 3 different copies. And in each one we can start playing with the settings to see the difference. Let's also go to lights and camera, add a camera, control click. And let's lock the view so we can adjust the camera angle. Maybe something like this. Let's put you over here. And let's do a quick mplay. That's session 1. Let's do a frame range from 1 to 75. Okay, let's check this out. So now we have 3 identical collapsing grain boxes. And now we can start playing with the attraction weight setting. So I'll minimize this. One thing I'd like to do is I want to move the box a bit upwards so that it falls down instead of just collapsing. Okay, so we're going to keep the first one at 0 attraction weight. The second one we're going to do 0.03. And the third one we're going to do 0.09. Alright, so let's make a flipbook. Okay, so let's look at the results. So this is looking really good. We can definitely see more clumping on the third one. The second one is also much more compact because this one is going all over the place because it's very dry sand. So this gives you a good idea of what the attraction weight parameter is doing. So now let's play with the repulsion weight. So I want to set the attraction weight the same on these 3 now so we can see the difference in repulsion weight better. So I'm gonna go with the 0.031, which was our second one, as you can see here. So let's change it here as well. 0.03. Okay, so let's make repulsion weight 0 on the third one. And let's make it 0.5 on the second one. This one is 0. So let's do a new flipbook render and see what that looks like. So the results are very different yet again. So on the right one, none of the particles collide with each other, so it just remains in the same shape. Whilst on the left one, you can definitely see each particle pushes another particle out of the way, so it spreads more. But I think the middle one looks the best out of these 3. I suggest you keep playing with these settings until you find something that works for your project. But this was just to quickly show the 2 most important parameters in the vellum grain solver.